Hi everyone, my name is Ante Šiljeg. I work as an associate professor and the head of the Geospatial Analysis Laboratory at the Department of Geography, University of Zadar, Croatia. I'm pleased to participate in this international conference and also grateful to the scientific and organizing committee and reviewers for allowing our team to present 3 papers during this event. The major objectives of our lab are the development of new research methods, application and implementation of the modern knowledge and technology, performing advanced scientific and applied research with the GIS and remote sensing domains. Lab is equipped with the most up-to-date devices and accompanying software. Also, as a team, we participated in the implementation of the several projects, for example, PEPC, NetWap, Holistic, EcoC. In June 2019, we received an invitation from the lead partner, Zadar County, and development agency Zadar Nova to participate as a partners in the project Strategic Development of the Flood Management. This project will contribute to increase knowledge about floods in the areas involved. Local authorities and emergency services will improve their flood risk management, while people will learn caused by floodings. There are 20 participating agencies in the project, and the project total value reached an amount of 10 million euros. The role of our team is to collect and process interdisciplinary data sets from various sources and to create a GIS database that one of our external partners, Faculty of Civil Engineering, University of Rijeka, can use to develop flood hazard, susceptibility, vulnerability, risk models, and a flood risk management plan. Unfortunately, access to spatial data is still limited and difficult in the Republic of Croatia. The methodology for creating a flood risk management plan is not yet regulated by law. Therefore, in agreement with external expert for hydrological modeling, one of the goals of our project is to develop the new methodological framework for multiscale modeling of urban pluvial flooding, which I will present today at the conference with the co-authors. The main goal of the paper is to present the workflow and methodological framework of future activities on a STREAM project. Floods have been always a serious natural threats, significantly affecting many aspects of human activities and people's lives, especially in urban areas. Pluvial or rain-related floods are causing more and more damage to urban areas, usually occur when rainfall exceeds the capacity of the stormwater man-made drainage system. For example, the coastal part of Croatia recorded rainfall events with more than 200 liters of rain per square meter in less than 24 hours. In the future, an increase in urban sprawl, uncontrolled urbanization, and in extreme precipitation events are expected, which impose the need to develop a comprehensive methodological framework that could prevent and mitigate adverse consequences of a pluvial flood. There are numerous different approaches for modeling urban pluvial floods. High-quality data is necessary to create high-resolution models of urban pluvial floods. By increasing the spatial resolution of input data, it is possible to obtain precise flood maps. In this project, we also work on modeling fluvial floods at the 3 levels of research for 6 selected study areas. As an example for presentation in this paper, we have chosen Zadar as a case study area, dividing its territory into 3 levels of research: macro, meso, and micro. The city of Zadar is located in the middle of the eastern Adriatic coast. It consists of 37 local communities of which 12 are located on the islands. The coastal area of the Zadar is exposed to storm surges due to low relief, while the rest of the city is vulnerable to frequent pluvial floods caused by large catchment area and high percentage of impermeable surfaces and a poor drainage system. Methodology is divided into 3 levels of research: macro, meso, and micro. And here you can see methodological framework for modeling urban pluvial floods. The macro level of research encompasses the catchment area of the Zadar settlement. At this level of the research, surface elevation data will be collected by photogrammetric restitution by state geodetic administration and used to create digital terrain model. The most suitable interpolation method will be selected by evaluating various geostatistic and deterministic interpolation methods. Spatial resolution will be determined considering the number of samples and the size of the research area. Here you can see developed tool for automated process for generating digital terrain model that includes 5 steps in a digital digital terrain model production process. Satellite imagery Sentinel-2 with a spatial resolution of 10 meters will be used to create a land cover model using geographic object-based image analysis methodology. In the geographic object-based image analysis process, we tested 2 software, ArcGIS and eCognition, and various user-defined parameters that affect the output result. We also developed reference models based on which we perform model validation with several methods. Segmentation parameters and optimal classifier will be determined by classification accuracy assessment of several most used classifiers. Land cover model and derived parameters for digital terrain model will be used for more accurate modeling of surface flows, considering absorption characteristic of different soil types. Data from central register of spatial units will be used for generating flood sensitivity, vulnerability, hazard, and risk maps. The aim of this research level is to obtain information about the general hydrological characteristic, slope, imperviousness, infiltration, roughness of Zadar catchment area. The meso level of research encompasses the administrative border of Zadar settlement. At this level, aerial photogrammetric data, RGB plus infrared, from the state geodetic administration will be used to create digital surface model, digital terrain model, and land cover model with a spatial resolution about half meter. At this level, we had a problem because the state geodetic administration didn't want to provide us with the data on military facilities. After that, we decided to buy on WorldView 2 multispectral and stereo images. Segmentation parameters and optimal classifier for land cover model will be determined using the same scientific methods as the macro level of research. Central register of spatial units data will be updated with detailed facility and population data that will be acquired from different sources, open source data, field survey, etc. The modified data set will be used for the assessment of the flood sensitivity and the vulnerability maps, as well as the flood hazard and flood risk maps. Communal infrastructure data, for example, manholes, pipe flows, drainage system, will be collected from the local municipality, public utility companies, and the field surveys in order to develop high-quality input data and support pluvial flood modeling. The goals of this research are to obtain information about a detailed hydrological characteristic with the catchment settlement of Zadar, and define the most flood-prone location to pluvial floods using a multi-criteria decision analysis. The micro level of the research will encompass the small pilot area within the Zadar settlement with a total area of up to 5 hectares, an urban block sub-catchment. Within the defined test area, aerial photogrammetric RGB plus multispectral imagery, terrestrial laser system, and aero laser system data, all with spatial resolution of 5 cm, will be conducted. This high resolution data will be used to create digital surface model, digital terrain model, and land cover model. The aim of this research is to determine which amount of runoff is affected by wastewater and other pollutants. Research goals at the micro level are to perform detailed analysis of obtain very high quality information of the hydrological process within the most flood-prone location within Zadar, and to purpose smart solution such as a sustainable urban drainage system to mitigate pluvial floods and reduce its negative effect on the environment. The main purpose of pluvial flood modeling in urban areas is to obtain result for preparation of the flood hazard maps, which will be used to prepare flood risk maps. Flood hazard maps will be derived for 3 scenarios: floods with a low probability or extreme event scenario, 100 years return period, floods with a medium probability, 20-year return period, and floods with a high probability, 5-year return period. For each scenario, the following elements will be computed and illustrated on the flood hazard map: the spatial flood extent, water depth or water surface elevation, flow velocity, or relevant water flow. Pluvial floods in urban area will be simulated by 2D hydrologic model and all 3 levels. The hydrologic model will have subgrid bathymetry to include irregular bathymetry at each computational cell. Furthermore, the hydrologic model will have the option to account for spatially and temporally variable rainfall and spatially variable infiltration. Considering that pluvial floods are generated by extreme rainfalls, spatial attention will be placed on the selection of appropriate designed storm to describe a synthetic hydrograph. For this purpose, several approaches will be considered at the pilot site, including the alternating block method, Euler type 2, half curves, and the average variability method. Thank you for your attention.